Out there, in the absolute and unforgiving cold, lies an endless expanse. It is a dominion of silence, punctuated only by the whisper of ancient light. For eons, humanity has looked up into this great dark ocean and seen reflections of itself, its past, and its potential future. We built stories around the pinpricks of brilliance in the night, crafting mythologies of gods and heroes from stellar patterns. Then, we built instruments of glass and metal, extensions of our own eyes, and began to decipher the true nature of this cosmic tapestry. We learned that each spark was a sun, many grander than our own. We discovered that these suns were gathered into colossal islands of light, vast stellar cities that we name galaxies. Our own home, the Milky Way, is but one of hundreds of billions, perhaps trillions, of these magnificent congregations of matter and energy. With this knowledge came a framework, a grand narrative of cosmic history. A story that begins with a singular explosive moment of creation and unfolds over 13.8 billion years of methodical, predictable evolution. This story, our standard model of cosmology, is a monumental achievement. It tells us how the universe expanded, how matter clumped together, how the first stars ignited, and how these stellar metropolises slowly formed. It is a story that for decades has been confirmed by every observation we have made. It is a reliable, tested, and beautiful chronicle of all that is. But what if a discovery was made that did not fit the narrative? What if, in the deepest, most remote corner of the observable universe, we found something that defied every chapter of that grand story? This is the tale of such a discovery. It is the account of a journey to a place we never thought could exist. It is the chronicle of MACE 107.1, the galaxy that should not be there. To understand why this particular island of stars is so profoundly unsettling, we must first travel back in time, not just for centuries, but for millennia. We must return to the dawn of human curiosity, when the cosmos was a two-dimensional ceiling painted with divine fire. The ancient Greeks, brilliant in their geometry and philosophy, imagined a universe of crystalline spheres, with Earth at its serene centre. This geocentric model, championed by Ptolemy, was elegant and intuitive. It held sway over the Western mind for over 1400 years. It was a comfortable universe, one designed with humanity at its heart. But the cosmos rarely bends to our comfort or intuition. Then came a revolution, a cascade of daring ideas from minds like Copernicus, who dared to place the sun at the centre of our local system. Galileo Galilei, aiming his newly crafted telescope at the heavens, shattered the crystalline spheres forever with his observations. He saw moons orbiting Jupiter, proving Earth was not the centre of all motion. He witnessed the phases of Venus, a phenomenon only possible in a sun-centred system. He resolved the faint milky band across the sky into a vast multitude of individual stars. The universe was suddenly deeper, grander, and more mysterious. Our demotion from the centre of everything had begun. Centuries later, a new generation of astronomers continued this outward push. In the early 20th century, the debate raged. Was our Milky Way the entire universe, or were the faint spiral-shaped nebulae distant galaxies in their own right? An astronomer named Edwin Hubble, using the colossal Hooker telescope on Mount Wilson, settled the argument once and for all. By observing special pulsating stars called Cepheid variables in the Andromeda Nebula, he calculated its distance, proving it was a staggering 2 million light-years away. It was an island universe, a separate galaxy as large as our own. The known universe exploded in size in a single breathtaking moment. Humanity was not living in the capital city of the cosmos, but on a quiet suburban street in an incomprehensibly vast metropolis. Hubble's revelations did not stop there. As he measured the distances to more and more of these remote stellar systems, he noticed something extraordinary in their light. The light was stretched, shifted towards the red end of the spectrum. This redshift was a cosmic Doppler effect, indicating that these galaxies were moving away from us. And the farther away a galaxy was, the faster it seemed to be receding. The conclusion was as inescapable as it was world-altering. The universe itself was expanding. It was not a static, eternal stage, but a dynamic, evolving entity. This single observation became the bedrock of modern cosmology. If the cosmos is expanding now, it means that in the past, it must have been smaller. Winding the cosmic clock backward, everything must have been closer together. Further and further back, all the matter and energy of the observable universe would have been compressed into an infinitesimally small, unimaginably hot, dense point. This was the genesis of the Big Bang theory, first proposed by Georges Lemaitre. It was a theory so radical it was initially met with ridicule. But evidence began to mount. In 1964, two radio astronomers, Arno Penzias and Robert Wilson, were trying to eliminate a persistent faint hiss from their large radio antenna. This noise came from every direction in the sky, day and night, with uniform intensity. They had stumbled upon the afterglow of creation itself. This was the cosmic microwave background radiation, the remnant heat from the Big Bang, an echo of that initial fireball now cooled by 13.8 billion years of expansion. The discovery transformed the Big Bang from a speculative idea into a testable theory. Our grand narrative of cosmic history now had a definitive beginning. The story could be written. The first chapter is one of unimaginable violence and energy. In the first fractions of a second, the universe inflated at a staggering rate, expanding from smaller than an atom to larger than a galaxy. Fundamental forces and particles precipitated out of the primordial energy soup. For the first 380,000 years, the cosmos was a blazing, opaque fog of plasma. Light was trapped, unable to travel freely, constantly scattering off charged particles. Then, the universe cooled enough for protons and electrons to combine, forming neutral atoms. Suddenly the fog cleared. Light was set free to travel across the cosmos, and this is the light we see today as the cosmic microwave background. But this moment also marked the beginning of a new era, the cosmic dark ages. There were no stars, no galaxies, no sources of new light. The universe was filled with vast, silent clouds of hydrogen and helium gas, drifting through an all-encompassing darkness, illuminated only by the fading primordial glow. According to our standard model, this darkness was not uniform. The cosmic microwave background shows us that there were minuscule fluctuations in density, tiny regions that were infinitesimally denser than their surroundings. These were the seeds of all future structure. Gravity, the patient, relentless sculptor of the cosmos, went to work on these seeds. Over hundreds of millions of years, gravity slowly, painstakingly, pulled these slightly denser regions of gas together. Imagine a near-perfectly smooth ocean, with ripples so tiny they are almost imperceptible. Over an immense timescale, gravity causes the crests of these ripples to attract more water, growing ever so slightly higher, while the troughs become emptier. The process is methodical, hierarchical, and above all slow. It is a bottom-up construction. Small things must form first. The first things to form were not galaxies, but individual stars. These were the fabled Population 3 stars, the very first generation of suns. They were forged from pure hydrogen and helium, the only elements available. Without heavier elements to help them cool, the gas clouds that formed them could only collapse under immense mass. These first stars were therefore theorized to be true monsters, hundreds of times more massive than our own sun, blazing with a furious blue-white light, 1,000,000 times more luminous than anything we see today. But their lives were extraordinarily brief. They burned through their nuclear fuel in a mere 1 or 2 million years, a cosmic heartbeat before exploding in cataclysmic supernova. These first explosions were profoundly important. They were the crucibles that forged the first heavy elements in the universe, elements like carbon, oxygen, and iron, everything essential for planets and for life. They seeded the surrounding gas clouds with this new material. Only after this seeding, after multiple generations of these first stars lived and died, could the process of galaxy formation truly begin. Gravity would continue its work, pulling these enriched gas clouds and small star clusters together. Tiny protogalaxies would form first, little more than glorified star clusters. Over hundreds of millions, even billions of years, these smaller structures would merge and collide, slowly building up into larger and larger galaxies. It is a painstaking process of cosmic acquisition and assembly. A grand, mature spiral galaxy like our Milky Way, or a colossal elliptical one, should take billions of years to construct. It requires time for stars to form, die, and enrich the interstellar medium. It demands time for gravity to organize billions of stars into stable, rotating disks and spiral arms. It needs time for a central supermassive black hole to gradually grow by feeding on gas and other stars. This is the established, elegant and well-supported timeline of our universe. A timeline that dictates that in the dawn of the cosmos, you should only find small, messy infant galaxies still in the process of becoming. You should not find a fully formed, mature and massive galactic metropolis. And that is precisely why the first blurry images of MACE 107.1 sent a shockwave through the astronomical community. The discovery was not a singular eureka moment, but a slow, creeping realization. It began in the sterile, climate-controlled data centers that serve a new generation of cosmic observatories. These are not the romantic, solitary domes of the past. They are technological titans like the James Webb Space Telescope, orbiting far beyond Earth, its golden mirror shielded from the sun's warmth, allowing it to peer into the infrared universe with unprecedented sensitivity. It is a time machine, purpose-built to capture the faint redshifted light from the very first stars and galaxies, light that has been travelling for over 13 billion years. A team of cosmologists had been using this magnificent instrument to conduct a deep-field survey, staring at a tiny, seemingly empty patch of sky for hundreds of hours. The goal was to build up a census of the earliest galactic structures. Among the thousands of faint red smudges in the resulting image, one stood out. It was designated MACE 107.1, just another number in a vast catalogue. But there was something wrong with it. The initial data suggested its light had travelled for 13.5 billion years. This meant we were seeing it as it was just 300 million years after the Big Bang. This is the absolute frontier of cosmic observation, the era when the very first galaxies were supposed to be just flickering into existence, like cosmic embers. But the smudge was too bright. It was far too luminous. The first reaction in the science team was skepticism. Mistakes are common at the cutting edge of research. Perhaps it was an instrumental artifact, a glitch in a detector. They ran diagnostics. The instrument was performing flawlessly. Perhaps it was closer than it appeared, a foreground galaxy masquerading as a distant one. They began the arduous process of spectroscopy, splitting the galaxy's faint light into its constituent colours, its chemical fingerprint. The spectrum would reveal its true redshift, and thus its true distance, without ambiguity. The team waited for weeks as the data trickled in, photon by painstaking photon. When the final spectrum was assembled, a hushed silence fell over the control room. The redshift was enormous, even larger than initially estimated. MACE 107.1 was unequivocally a resident of the early universe. It was not a masquerader. The problem was real. The brightness suggested a galaxy with a stellar mass of over 10 billion suns. This was not an ember, it was a cosmic bonfire. To assemble 10 billion suns worth of stars and gas in just 300 million years is a task that our cosmological models deemed impossible. It's like finding a 100-story skyscraper fully built and occupied just a few weeks after the bedrock for its foundation was laid. The sheer speed of formation was staggering. The standard bottom-up model of slow, hierarchical assembly simply could not account for it. It would require a star formation rate hundreds, even thousands of times greater than anything observed in the local universe, a rate so extreme it would have torn the nascent galaxy apart with supernova explosions. The anomaly was so profound the team leader initially refused to publish, convinced they were missing something obvious. They explored every alternative explanation. Could the light be magnified by gravitational lensing? This is a phenomenon where the gravity of a massive foreground object, like a galaxy cluster, acts like a cosmic telescope, bending and amplifying the light from a more distant object behind it. They scoured the field of view for any such massive lens. There was nothing. MACE 107.1 appeared to be shining with its own, intrinsic, impossible brilliance. The mystery only deepened as they analysed the spectral data further. The light signature revealed more than just distance. It revealed composition. They found the unmistakable spectral fingerprints of carbon, nitrogen, and oxygen. These are not elements created in the Big Bang. They are the products of stellar fusion, the ash left behind by dying stars. To find them in such abundance in a galaxy so young was a second impossibility. Think of the early universe as a pristine new kitchen, stocked only with two ingredients, hydrogen and helium. To bake a complex cake, you need flour, sugar, eggs, elements created inside stars. Each star is an oven. A massive star bakes these heavier elements in its core, and then, when it explodes as a supernova, it scatters these new ingredients into the kitchen. The next generation of stars can then incorporate these enriched materials. This process takes time. Many generations of stars must live and die. Our own sun is a third-generation star, rich in the recycled ashes of its ancestors. MACE 107.1, existing just 300 million years into cosmic history, should have been made almost exclusively of the primordial ingredients. It should have been a population 3-star galaxy. Instead, its chemical profile looks surprisingly mature, like a galaxy a billion years older. It was as if someone had come into that pristine kitchen and instantly filled the cupboards with every complex ingredient imaginable. Where did all these heavy elements, this metallicity, come from so early in the game? The timeline for stellar evolution and enrichment seemed to be fundamentally broken, and then the telescope's instruments detected something else, a source of intense, high-energy radiation emanating from the galaxy's core. It was the signature of an active galactic nucleus, a supermassive black hole furiously consuming gas and dust, releasing enormous amounts of energy. This in itself was not a surprise. We expect large galaxies to have these central engines. The shock was its size. Based on the radiation output, the team calculated the mass of the black hole. The number that came back was staggering, over 1 billion times the mass of our Sun. This was not just a third impossibility. It was a cosmological nightmare. Supermassive black holes are thought to grow over immense timescales. They start as smaller seed black holes, perhaps from the collapse of the first massive stars. Then, they grow by two main processes: accreting gas from their host galaxy and merging with other black holes during galaxy collisions. Both are relatively slow, methodical processes. To grow a black hole to 1 billion solar masses normally takes billions of years. The black hole at the centre of MACE 107.1 had reached that colossal size in a mere 300 million years. It would have had to consume matter at a rate far exceeding what is thought to be physically possible, a limit known as the Eddington limit, where the outward pressure of radiation from the accreting material would blow away any more incoming fuel. This black hole wasn't just big, it was obese. It had grown impossibly fast. It was a giant in a land that should only contain infants. MACE 107.1 was not just one anomaly. It was a trifecta of cosmological paradoxes. It was too massive, too chemically evolved, and hosted a black hole that was too large for its age. It was a fully formed middle-aged system existing in the universe's nursery. It was the galaxy that our best science said could not and should not exist. To truly grasp the alien nature of this place, let us embark on a journey. Leave Earth behind and watch as our blue marble shrinks to a pale dot. Push past the orbits of our planetary neighbours, beyond the Kuiper Belt's icy frontier. Our own sun becomes just another star, lost in the luminous river of the Milky Way. We accelerate, crossing the vast emptiness between spiral arms, a 100,000 light-year journey completed in a moment. Our galaxy, with its 200 billion stars, recedes behind us, a majestic spinning pinwheel. We push further into the local group, past our great neighbour Andromeda. Then, into the intergalactic void, a darkness more profound than any human has ever known. The journey stretches for millions, then billions of light years. We are now travelling back in time, the light from distant galaxies becomes older, redder. We witness the cosmic web, the largest structure in the universe. Vast filaments of dark matter and gas stretch across hundreds of millions of light years, and at their intersections, clusters of galaxies glitter like jewels. But we must go further, beyond this mature, well-ordered universe. We travel deeper into the past to an era before the grand structures had formed. The cosmos becomes more chaotic, filled with smaller, misshapen, colliding galaxies. We are now more than 13 billion years in the past. The universe is a murkier, more compact place. The darkness is punctuated by the brilliant, ferocious light of the first stars, and there, in the distance, is our destination. MACE 107.1, 7 point. It does not look like the elegant spirals we know. It is a turbulent, violent, brilliant knot of creation. It is compact, but blazes with an intensity that belies its size. Vast regions of incandescent pink and blue gas signal frenetic starbirth on a scale that makes our own galaxy's star-forming nebulas look like placid clouds. Massive, blue-white stars, 1,000 times brighter than our Sun, live and die in mere moments, exploding as supernovae that pepper the galactic disk with incandescent shockwaves. The light is harsh, unfiltered, dominated by the raw ultraviolet radiation of these stellar monsters. There are no gentle golden suns here, no stable, long-lived stars. This is a realm of cosmic violence and rapid creation, and at its very heart, invisible to the eye but dominating the region with its gravity, is the quasar, the active supermassive black hole. A disk of superheated gas torn from stars and interstellar clouds swirls around the event horizon at nearly the speed of light. It glows with the energy of 1 trillion suns, a celestial blowtorch that outshines the entire galaxy that hosts it. 2 colossal jets of plasma and radiation erupt from its poles, punching through the galactic plane and extending for thousands of light years into intergalactic space. This is the engine that powers the impossible, but it does not solve the mystery, it deepens it. How did this maelstrom of mature, complex activity arise so quickly from the quiet darkness? The existence of MACE 107.1 forces us to question the very foundations of our cosmological model. If the model is wrong, what can we replace it with? Scientists are now grappling with this question, exploring ideas once relegated to the fringe. One possibility is that our understanding of the cosmic dark ages is flawed. Perhaps things got started much, much earlier than we thought. The process of gravitational collapse may have been accelerated by factors we don't yet comprehend. Maybe primordial black holes, formed in the first second of the Big Bang, acted as gravitational anchors, rapidly pulling in matter and seeding galaxies far faster than we imagined. This would help explain the impossibly large black hole at the centre of MACE 107.1. It wasn't grown, it was born large. This is the direct collapse model where a gargantuan cloud of primordial gas collapses directly to form a massive black hole, bypassing the star formation stage entirely. It is a radical departure from the standard bottom-up picture. Another line of inquiry focuses on those enigmatic first stars, the population 3 stars. Our models describe them as massive and short-lived, but what if they were even more extreme? What if there was a class of supermassive stars, tens of thousands of times the mass of the Sun? Such behemoths would have burned through their fuel in a cosmic flash, then collapsed into massive black holes, providing the seeds for later growth. Their explosive deaths would have also enriched the cosmos with heavy elements at an astonishingly efficient rate. A single generation of such monsters could potentially explain the mature chemical signature of a galaxy like MACE 107.1. The problem is, we have never seen such a star, and they may have only existed in the very specific conditions of the primordial universe. Or perhaps the answer lies not in the visible matter, but in the unseen. Over 85% of the matter in the universe is dark matter, an invisible substance whose gravitational influence we can measure, but whose nature remains a profound mystery. Our standard model, the lambda-CDM model, assumes this dark matter is cold, meaning its particles move slowly and clump together easily, forming the gravitational scaffolding upon which galaxies are built. But what if dark matter is more complex? What if some of it is warm, or interacts with itself in ways we haven't predicted? A different kind of dark matter could lead to a different kind of gravitational collapse, one that allows structures like MACE 107.1 to form with shocking rapidity. This single, distant galaxy could be the key that unlocks the true nature of the dark universe. The most profound and unsettling possibility is that our entire understanding of gravity and cosmology on the larger scales is incomplete. MACE 107.1 might be a signpost pointing toward new physics, a fundamental revision of Einstein's theory of general relativity, or a hint that the universe's expansion was not as smooth as we believe. Perhaps there were epochs of rapid, localized structure formation. The implications are dizzying. The discovery of a MACE 107.1 is more than just an astronomical puzzle, it is a lesson in cosmic humility. For centuries, we have constructed a story of the universe, and we have grown comfortable in it. We believed we had sketched the main outlines of the 13.8 billion year epic. But this single point of light, this ghost from the dawn of time, tells us that we might have the story wrong. There may be missing chapters, or the plot may be far more complex than we ever conceived. It forces us to confront the fact that our knowledge is a small island in an immense ocean of ignorance. Every time we build a more powerful telescope, a more sensitive detector, and push the boundaries of observation, the universe rewards us with a new mystery. It presents us with objects that defy our explanations and shatter our certainties. MACE 107. One is the latest and perhaps greatest of these beautiful challenges. It is a reminder that science is not a collection of immutable facts, but a dynamic process of questioning, exploring, and being willing to be proven wrong. The astronomers studying this impossible galaxy are not discouraged. They are galvanized. A paradox is not a failure. It is an opportunity. It is the doorway to a deeper understanding, a more profound truth. The journey to MACE 107.1 is far from over. Future observatories will stare deeper, gathering more light, untangling its secrets. And in its turbulent, brilliant heart, we may find the answers to some of our oldest questions. How did the cosmic web take shape? How are supermassive black holes truly born? And was the birth of our universe a simple, straightforward process, or was it a far stranger, more violent, and more creative event than we ever dared to imagine? The galaxy that should not exist is waiting. And its very existence is a promise that the grandest discoveries about our universe are still ahead of us, hidden in the faint light from the very edge of time. Look out into the deepest night you can imagine, far from the glare of cities under a canopy of pure darkness. You are seeing a river of light, a luminous spill of diamond dust. It is a spectacle so vast it seems to defy all sense of scale. This is your home seen from the inside out. This is the Milky Way galaxy. It appears as a gentle, shimmering band across the heavens, a soft, celestial glow that has captivated humanity for all of time. But this serene appearance is a profound illusion. You are not looking at a peaceful river. You are witnessing the edge of a raging, incandescent storm, a colossal spinning vortex of 400 billion suns. Each point of light is a star many far larger and brighter than our own, and between them great clouds of iridescent gas and shadow. These are the stellar nurseries, the birthplaces of new suns, cosmic canvases painted with the light of newly ignited fusion. And there are the graveyards, the remnants of suns long dead, the glittering embers of white dwarfs and the dark echoes of supernovae. Our galaxy is a place of unimaginable violence and breathtaking creation, a self-contained universe of spiraling arms, each one a kingdom of stars. Our own sun is just one citizen among countless billions, a tiny speck of light in the Orion Arm, a minor suburb of this city. and like every other star, every planet, every asteroid, and every wisp of gas, our sun is in constant sweeping motion. We are all caught in a majestic silent dance, a cosmic waltz choreographed on a scale of 100,000 light years. Every object you can see and countless more you cannot are all bound together in a single gravitational embrace. They are all falling all the time around a common unseen center, a gravitational sovereign that dictates the motion of everything. For centuries we could only guess what lay there. At the very heart of that luminous storm, the core of our galaxy is shrouded from our view, hidden behind impenetrable veils of interstellar dust and gas, a thick, dark curtain that our most powerful optical telescopes cannot pierce. It was a mystery locked away in the galaxy's most luminous, most crowded room. Imagine trying to see the center of a hurricane from within it. That is the challenge our astronomers faced, but humanity is persistent, and our curiosity is a relentless engine. We learned to see in new kinds of light beyond the visible spectrum. We built eyes that could perceive the universe in radio waves and infrared, wavelengths that could slip through the cosmic dust like ghosts. And when we finally parted that celestial curtain, when we finally focused our new vision on the deepest heart of the Milky Way, we found something more astonishing than we ever dared to imagine. The center was not a colossal star or a dense cluster of suns. It was a place of pure, terrifying physics, a region of impossible density and unimaginable speed. We saw stars there, ancient and massive, moving with frantic velocity. They were not wandering but were locked in tight, furious orbits, swinging through space at millions of miles per hour. Like planets slingshotting around a sun of impossible power, they whipped around corners in space-time so sharp it defied belief, some completing their orbits in a matter of mere years, a journey our own sun takes 230 million years to complete. These central stars were accomplishing in a human lifetime. This was a cosmic crime scene, and the evidence was overwhelming. The motions of these stars, their incredible accelerations, could only be explained by one thing. They were all bowing to the will of a single invisible object, an object of such immense gravitational authority that it holds 250 billion solar systems in its sway. This silent conductor of the galactic orchestra is called Sagittarius A, and it is a supermassive black hole, a monster 4 million times the mass of our own sun, crushed down into a volume smaller than the orbit of Mercury. It is the axle around which our entire galaxy turns, the dark, silent monarch on a throne of warped space-time. Its presence is the reason our galaxy has structure, the reason the spiral arms have not long since flown apart into the void. It is the anchor, the foundation, the unmoving center, the gravitational bedrock upon which our entire cosmic island is built. Our sun, our planet, your body, you are orbiting it right now, moving at 500,000 miles per hour through the void, held in its lane by the invisible leash of Sagittarius A's gravity. It is the ultimate destination, the point of no return at the galaxy's core, a place where the rules of physics as we know them break down, where space and time collapse into an unknowable singularity. We have come to understand this place with astonishing clarity. We have mapped the orbits of the stars that dance closest to its edge. We have even taken a picture of its shadow, a ring of light, formed by photons bent into a perfect loop by its gravity. It is a triumph of human intellect and persistence, a testament to our ability to comprehend the incomprehensible. We have found our galaxy's center of gravity, the fulcrum that balances 400 billion suns. It seems for a moment that we have found our ultimate cosmic address, a fundamental point of reference in the vastness of space, a still point in the turning universe, the one thing that everything else moves around. And for a long time this was a comforting thought. It gave us a sense of place, a sense of order. Our chaotic, sprawling galaxy had a definitive center. An absolute monarch whose rule was eternal and whose position was fixed. It provided a final answer to the question of our galactic motion. We orbit the Sunday, the Sun orbits Sagittarius A. The story ends there. But there is a flaw in this beautiful, orderly picture. A loose thread in the tapestry we have so carefully woven. A quiet discovery made not with a sudden flash of insight, but through years of patient, painstaking observation, the work of astronomers who stare into the abyss for a living, who track the faintest whispers of light from the edge of creation. These cosmic cartographers, these celestial detectives, found a way to measure the unmeasurable. They needed to know if our galactic anchor was truly anchored, if our still point was truly still. To do this, they needed a reference point outside our galaxy, something so distant it would be effectively motionless. They found their answer in quasars, the hyperluminous hearts of galaxies billions of light years away. These objects are the most distant and stable beacons in the cosmos, lighthouses shining from across the entire breadth of the observable universe. By comparing the position of Sagittarius A to these immovable cosmic landmarks, they could detect even the slightest hint of motion. For years they watched, they measured, they calculated, in quiet control rooms under the dim glow of computer screens. While the world slept, they sifted through mountains of data, looking for a subtle drift, a tiny deviation, a change so small it was like measuring the width of a human hair from hundreds of miles away. And slowly, painstakingly, the answer began to emerge, an answer that was both unsettling and thrilling, an answer that would once again shatter our sense of place and open up an entirely new chapter in our cosmic story, because the data was unambiguous, the conclusion inescapable. Sagittarius A is not still. Our galaxy's anchor is not anchored at all. The dark throne at the heart of the Milky Way is not stationary. It is moving, and it is moving with astonishing speed. Right now, our supermassive black hole and our entire galaxy with it is hurtling through the universe at 1.3 million miles per hour. Let that sink in for a moment. The very object that defines the center of our cosmic home, the gravitational bedrock for 400 billion suns, is itself adrift on a much larger unseen current. It is not a final destination, but just another traveler on a cosmic voyage. Our entire galaxy, a spinning island of light, is a ship sailing an infinite ocean. This revelation is profound. It demolishes our neat and tidy galactic hierarchy. It takes our map of the cosmos and tears it to pieces, because it forces us to ask a question so simple and yet so deep. It may be the most fundamental question we can ask about our place in the universe, a question that drives the narrative of this entire story. If our sun and all its neighbors orbit the galactic center, if every star, every nebula, and every cluster is a subject in its kingdom, if everything we have ever known is falling towards Sagittarius A, then we must ask the next unavoidable question. What does Sagittarius A orbit? What colossal unseen structure has the gravitational authority to command the allegiance of an entire galaxy? What is the center of this even grander cosmic dance? Where are we all going in such a tremendous hurry? This is not just a question of astronomy. It is a question of identity, of belonging, of our ultimate origin and destination. To answer it, we must leave our familiar galaxy behind. Our journey must take us out into the shocking emptiness between the galaxies, into the intimidating darkness of the intergalactic void. We must learn to see the universe not as a collection of individual stars, but as a tapestry of galaxies, a foam of cosmic structures, stretching for billions of light years in every direction. The search for this answer is not glamorous. It is not a story of eureka moments and sudden breakthroughs. It is a tale of quiet, relentless dedication. It is the story of the sleepy scientists, The men and women who sacrifice their nights for a few precious photons, who spend their careers listening for the faintest signals from the dawn of time. They work in lonely mountaintop observatories shivering against the cold, or in basement computer labs, their faces illuminated by cryptic lines of code. They are the unsung heroes of our cosmic journey, patiently connecting the dots one distant galaxy at a time. Slowly, meticulously, they are drawing the next grander map, a map that will show us our true place in the totality of existence. This is their story. It is a quest to understand the largest structures in the universe, to trace the invisible rivers of gravity that guide the galaxies, and to find the heart of everything. Our journey will take us to the Great Attractor, a mysterious gravitational anomaly, a place our galaxy is being inexplicably pulled towards. We will explore the Lania supercluster, our home cluster of 100,000 galaxies, an incomprehensibly vast structure whose existence we only recently discovered. We will confront the cosmic microwave background radiation, the fossil light from the Big Bang itself, and see how our motion through the universe is imprinted upon it. A cosmic speed ticket that tells us just how fast we are truly moving. So join us as we step outside our Milky Way and venture into the staggering emptiness of the great cosmic dark. We will follow the clues hidden in the subtle motions of galaxies and in the faint glow of the universe's first light, in pursuit of an answer to that one profound, destabilizing question. If the center of our world is falling, where is it falling to? Right now you are hurtling through space at 500,000 miles an hour. You don't feel it, of course. The Earth, the Sun, our entire local cluster of stars are all passengers on an immense, silent cosmic carousel. We are all falling in a grand, arcing trajectory that will take 230 million years to complete just one single turn. But falling towards what? What is the anchor point for this celestial waltz? What commands the allegiance of 100 billion stars? For most of human history, that question was unanswerable. The heart of our own galaxy, the Milky Way, was a forbidden kingdom. It was veiled from our sight, shrouded by impenetrable curtains of interstellar dust and glowing incandescent gas. We could look out away from the core towards other island universes, but we could not look in. The galactic center remained a profound, tantalizing mystery, a capital city whose existence we inferred, but whose throne room we could never see. It was a source of frustration for astronomers, a blank space on our map of reality. Imagine trying to understand a storm by observing only its outermost breezes. That was our predicament. We lived within a colossal structure, a spiral of stars and worlds, yet its fundamental engine, its organizing principle, was entirely hidden from us. All of our optical telescopes, no matter how powerful, were rendered blind. The light from the galactic heart simply could not complete the 26,000 light-year journey to Earth. It was absorbed, scattered, and lost in the cosmic fog between here and there. So we looked for another way in. If we could not see with light, perhaps we could learn to listen. In the 1,930 seconds, a young engineer named Carl Jansky was hunting for the source of static that was interfering with transatlantic radio communications. He built a strange rotating antenna, a primitive ear pointed at the heavens. Day after day he recorded a persistent, gentle hiss. He soon realized this static was not of earthly origin. It rose and set with the stars. He had detected a signal coming from beyond our solar system, and the strongest point of this cosmic static, the loudest part of this celestial whisper, came from a single direction. It pointed directly toward the constellation Sagittarius. It pointed toward the hidden center of our Milky Way. Jansky had for the first time heard the voice of the galaxy's core. It wasn't a language we could understand, not yet. It was a clue, a single ghostly breadcrumb dropped in the cosmic forest, inviting us to follow, to push deeper into the darkness. Decades passed. Our technology for listening to the universe grew ever more sophisticated. We built vast arrays of radio telescopes, metallic dishes that blossomed in remote deserts, all synchronized to act as a single planetary-sized ear. And as our hearing sharpened, that general hiss from Sagittarius resolved itself. It focused into an incredibly small, astonishingly bright point of radio energy. Astronomers named it Sagittarius A star, SCRA A, and it was immediately profoundly strange. Here was an object that screamed into the cosmos with the radio frequency energy of 1,000,000 suns. Yet when our most powerful infrared telescopes, which can pierce some of the dust, peered at its location, they saw nothing, absolutely nothing. This was a cosmic paradox of the highest order. It was like hearing a thunderclap from a clear blue sky. Something had to be there, something unimaginably powerful, something that could generate this furious torrent of energy and yet remain utterly stubbornly invisible. Theories swirled. Perhaps it was a cluster of neutron stars, the collapsed cores of massive suns orbiting each other in a chaotic, energetic swarm. Perhaps it was some exotic, undiscovered celestial object. But one idea, the most unsettling of all, lingered at the edge of scientific thought. An idea born from Einstein's equations. The notion of a place where gravity becomes so absolute, so tyrannical that it crushes matter out of existence and consumes light itself. The idea of a black hole, but to prove it to move from tantalizing theory to undeniable fact was a challenge of staggering proportions. It would require an investigation spanning decades. It would demand the invention of entirely new technologies, and it would ignite one of the greatest, most patient quests in the history of science. The mission was simple in concept but nearly impossible in practice. If there truly was a monster lurking in the dark, a supermassive black hole, it would have an immense gravitational field. Any stars unfortunate enough to be near it would be caught in its grip. They would be forced into orbits like planets around a sun, but at speeds and on paths that would defy belief. If we could track those stars, if we could plot their mad dance around the void, we could weigh the darkness, we could measure the mass of the invisible object they were circling. Two independent teams of astronomers on opposite sides of the world took up this monumental challenge. One led by Reinhard Genzel in Germany using the European Southern Observatory's telescopes in Chile, the other led by Andrea Ghez in California using the Keck Observatory in Hawaii. For them, the galactic center was a cosmic crime scene. The invisible perpetrator had left behind witnesses, the stars. Their job was to interrogate those witnesses, to follow their movements, and force them to reveal the nature of their unseen captor. But the obstacles were immense. Even with the most powerful infrared telescopes, the view was frustratingly blurry. Our own planet's atmosphere, the very air we breathe, distorts the light from distant stars. It makes them twinkle, a phenomenon that might be romantic for poets, but is a source of profound aggravation for astronomers. This atmospheric turbulence smeared the light from the galactic core, turning what should have been sharp pinpricks of starlight into fuzzy, overlapping blobs. It was impossible to tell one star from another, let alone track their precise motion year after year. It was like trying to follow a specific bee in a distant, vibrating swarm. The problem seemed insurmountable. To solve it, both teams turned to a revolutionary technology called adaptive optics. It is one of the most brilliant tricks in the astronomer's toolkit. The system works by shining a powerful laser into the sky, creating an artificial star high in the atmosphere. A computer measures exactly how the atmosphere is distorting the light from this artificial star. It then calculates the precise opposite distortion needed to cancel it out. Those corrections are sent hundreds of times per second to a flexible, deformable mirror in the telescope, a mirror that contorts its shape with microscopic pistons. It is in effect a form of cosmic noise cancellation. It untwinkles the stars. The result is breathtaking. The blurry, indistinct smear of the galactic center snaps into sharp, crystalline focus. Suddenly, individual stars emerge from the haze like diamonds scattered on black velvet. For the first time, we had a clear view of the suns living in the most extreme neighborhood in our galaxy. Now the real work could begin. The long, patient stakeout. Year after year for more than 2 decades, the teams returned to their telescopes. They captured image after image of this tiny patch of sky. Slowly, painstakingly, they began to map the motions of the innermost stars. These were not the stately, calm orbits we see in our own solar system. This was a scene of controlled gravitational chaos. The stars, which astronomers call the stars, were moving with astonishing velocity. They were whipping around the central dark point like comets slung around a star careening through space at millions of miles per hour. They were moths dancing around a flame they could not see. And one star in particular became the key to unlocking the entire mystery. A star designated S2 by Genzel's team and S0-2 by Gez's. This single luminous sphere of hydrogen became the ultimate cosmic probe. Over the years, the astronomers watched it complete a long elliptical journey. It would swing far out, slowing down as it fought the pull of the central mass. Then inevitably, it would be drawn back in. It would accelerate, falling faster and faster toward the unseen heart of the mystery. It would reach a point of closest approach, a perilous hairpin turn where it would be traveling at over 17 million miles per hour, 3% the speed of light. Then, having survived its brush with oblivion, it would be flung back out into a wide arc to begin the 16-year-long journey all over again. This was the smoking gun. The teams had tracked a star through its entire orbit around nothing. A complete, perfect Keplerian ellipse around a point in space where nothing was visible. The laws of physics discovered by Johannes Kepler and Isaac Newton centuries ago are absolute. If you know the size of an object's orbit and you know how long it takes to complete that orbit, you can calculate the mass of the central body it is circling. The math is inescapable. And when the astronomers plugged the numbers for S2 into their equations, the answer they got was staggering. The invisible object at the center of the Milky Way has a mass equivalent to 4 million of our suns, 4 million solar masses. All of that gravitational influence, all of that reality-bending power was packed into a region of space smaller than the orbit of Mercury. This one calculation changed everything. It was a moment of profound, earth-shattering revelation. The case was closed. The identity of the invisible object was no longer in doubt. No cluster of stars could be that massive and that compact. It would be blindingly bright, and its own gravity would have ripped it apart long ago. No cloud of gas or dust could be so dense. No other known celestial object fit the description. By a process of cosmic elimination, only one suspect remained. Sagittarius A star is a supermassive black hole, a true monster of the cosmos. It is not merely an object in space. It is a fundamental corruption of space-time itself, a gravitational singularity from which nothing, not even light, can escape. This discovery, the culmination of decades of tireless effort, earned Gez and Genzel the Nobel Prize in Physics. They had not just found an object, they had charted the geography of the impossible. They had proven that the dark heart of our galaxy is ruled by a gravitational tyrant, and its dominion is absolute. The frenetic dance of the stars is merely the most dramatic, most immediate display of its power. But its influence extends much, much further. The thousands of stars in the central cluster, the vast ancient globular clusters that hover like ghostly chandeliers above and below the galactic plane, they all feel its presence. They are all bound by its command. Even we out here in the quiet pastoral suburbs of the Milky Way are subjects of this distant, unseen monarch. Our sun, with its family of planets, is a willing participant in this grand, silent procession. Every 230 million years, we complete one vast circle around SGRA, one galactic year. Your life, your planet, your star, every atom in your body is currently describing a gigantic arc through the cosmos, tethered by an invisible gravitational thread to that central point. SGRA is the ultimate anchor. It is the hub around which the entire sprawling metropolis of the Milky Way revolves. It is the gravitational benchmark, the unmoving center against which all other motion is measured. Its authority is unquestioned, its power undisputed. It is the king on the throne at the center of it all, the very definition of what it means to be the thing that everything else orbits. This is the bedrock of our understanding, a cosmic certainty, a foundation built on decades of painstaking observation. And yet, a deeper, more unsettling question begins to emerge from this certainty. A question that seems at first to border on the absurd. If everything from the closest, most frantic stars to our own distant, placid sun is falling around this single supermassive point, if Sagittarius A star is the ultimate commander, what commands the commander? Does even a king have to bow? Is it possible that this anchor, this sovereign of 100 billion suns, is itself falling? That serene, majestic portrait of our Milky Way, a swirl of starlight against the velvet dark, is a comforting illusion. We imagine it as a great solitary island of light, a cosmic pinwheel turning gently in the eternal stillness of space. It feels permanent. It feels like a foundation. But this image etched into our collective consciousness is one of the most profound deceptions in the cosmos. Our galaxy is not an island. It is a vessel, and it is not still. It is hurtling through the void on a journey of unimaginable scale and consequence. The placid rotation of our home, the grand cosmic carousel we thought was the ultimate motion, is merely the gentle spinning of a ship caught in a violent unseen current. To truly understand the destiny of Sagittarius A star, we must first shatter this illusion of tranquility. We must zoom out beyond the familiar spiral arms, beyond the halo of ancient stars, and confront a terrifying, beautiful truth. We live in a universe of restless giants, a cosmos defined not by stillness, but by a relentless gravitational dance. For a brief, flickering moment in our history, we believed we were the universe, or at the very least, that our galaxy was the entirety of it. Those faint, ethereal smudges of light seen through early telescopes were thought to be nearby clouds of gas spiral nebulae belonging to our Milky Way. They were considered little more than cosmic weather, beautiful but local phenomena within our singular island of stars. The universe was vast, yes, but it was our vastness. It felt contained, understandable, knowable. Then, in the 1,920 seconds, a lone astronomer working high on a California mountain shattered that comfortable reality forever. Edwin Hubble, using what was then the most powerful telescope on Earth, aimed his gaze at one of those smudges, the Andromeda Nebula. He was searching for exploding stars novae to measure its distance. What he found instead was a specific type of star, a Cepheid variable, a celestial yardstick of impeccable reliability. Its flickering light carried an unmistakable message, a message that would tear down the walls of our perceived universe and throw open the doors to an abyss of unimaginable depth. Andromeda was not a nearby cloud. It was a sibling city of stars, another island universe, a galaxy in its own right, just like our own. And it was incomprehensibly far away. In that moment, the cosmos didn't just get bigger. It fractured into 1 trillion pieces. Our home was not the universe. It was one galaxy among billions, perhaps trillions, scattered through the darkness. This was the birth of the island universe theory, a paradigm that replaced one solitary kingdom with an endless archipelago of them, each galaxy a self-contained empire of stars separated from its neighbors by gulfs of black empty space so profound that crossing them seemed impossible. It was a lonely, majestic vision of the cosmos. But it too was incomplete, because a crucial clue, a subtle whisper of motion, had already been detected decades earlier. A quiet astronomer named Vesto Slipher, working under the pristine skies of Arizona, had spent years patiently analyzing the light from these spiral nebulae. He wasn't measuring distance, he was dissecting their very color. Using a spectroscope, he spread their faint light into a rainbow, looking for the telltale dark lines that betray the presence of different chemical elements. But he noticed something bizarre, something that defied explanation at the time. For nearly all the nebulae he observed, these spectral lines were not where they were supposed to be. They were shifted systematically toward the red end of the spectrum. It was as if the universe was singing a song, and every note was slightly flat. This phenomenon, the redshift, was a cosmic enigma. It was the first hint that these island universes were not anchored in place. They were running away from us. Hubble's later discovery of their immense distance, combined with Slipher's mysterious redshifts, led to the most staggering revelation in the history of science. The universe itself is expanding. The very fabric of space-time is stretching, carrying these galaxies along for the ride like raisins in a rising loaf of bread. This is not motion through space, but the motion of space itself. This discovery rewrote our understanding of everything. It meant the universe had a beginning, a moment of explosive birth in the Big Bang, and it confirmed that the cosmic archipelago was not static. It was a dynamic, evolving system. The silent, empty voids between the galaxies were growing wider with every passing second. Our comfortable illusion of a still universe was dead. But within this grand, overarching expansion, a more intimate and violent drama is unfolding. Gravity, the architect of stars and galaxies, was not rendered obsolete by the expansion of space. Its influence, though weakened by distance, is infinite. It sends out invisible tendrils, ghostly filaments of force that stretch across the millions of light years separating the galaxies. Where galaxies are close enough, where their mutual attraction is strong enough, they can defy the cosmic expansion. They can resist being pulled apart by the stretching of space-time and instead begin to pull on each other. They become gravitationally bound, a family held together against the outward tide of the universe. This is where our story takes its next turn, because our Milky Way is not a lonely castaway in the expanding ocean. We are part of such a family, a gravitationally bound collection of more than 50 galaxies, known with a simple but profound name, the local group. This is our cosmic county, our immediate gravitational neighborhood, and it is anything but peaceful. The local group is a chaotic, swirling system dominated by two titans. One is our own Milky Way. The other is its magnificent twin, that very same smudge of light that opened our eyes to the true scale of the universe. The Andromeda Galaxy. Slightly larger, more massive, and containing perhaps 1 trillion stars to our few 100 billion Andromeda, is our cosmic rival and our ultimate partner. These two giants, separated by 2.5 million light-years, are the undisputed sovereigns of this galactic realm. Their immense gravity dictates the fate of everything else around them. Orbiting these two behemoths is a swarm of smaller, fainter dwarf galaxies. Dozens of them. They are like moons orbiting planets, caught in the gravitational wells of the Milky Way and Andromeda. Some, like the Large and Small Magellanic Clouds, are our famous celestial companions, visible to the naked eye from the southern hemisphere. They are beautiful, irregular collections of stars, and they are currently being torn apart by our galaxy's gravity. We are a cannibal. We are slowly siphoning streams of gas and stars from these smaller galaxies, pulling them into long ethereal ribbons called tidal streams. Over hundreds of millions of years, they will be completely shredded and absorbed, their stars becoming indistinguishable from our own. This is the nature of life in the local group. It is a constant process of interaction, of collision, of mergers and acquisitions on a galactic scale. It is a cosmic ecosystem where the big eat the small. And in this dynamic, turbulent environment, nothing, absolutely nothing, sits still. Every galaxy in the local group is in motion, engaged in a complex gravitational ballet. They orbit a common center of mass, a point in the empty space between the Milky Way and Andromeda, pulled and nudged by their neighbors. This means our galaxy, our home, is not serenely gliding through the void. It is being yanked and tugged, jostled and steered by the gravitational influence of every other member of our local family. And the heart of our galaxy, Sagittarius, a star, is a passenger on this chaotic ride. The supermassive black hole, which we thought of as the ultimate anchor, the unmoving center of everything we know, is itself being pulled across the universe. Its grand orbit is not a perfect, isolated circle. It is a path dictated by the gravitational whims of dozens of other galaxies, both large and small. But even this complex local motion pales in comparison to the primary trajectory, the one great journey that dominates our future. The journey toward Andromeda. Remember Vesto Slipher's discovery that nearly every galaxy he saw was redshifted, moving away from us. There was one spectacular, glaring exception: Andromeda. Its light was not stretched toward the red. It was compressed toward the blue, a blue shift, the unmistakable signature of an object that is not receding but approaching, and approaching fast. All the complex dances of the dwarf galaxies, all the minor tugs and pulls, are merely background noise. The main event, the gravitational headline in our local group, is this: the two largest members, the Milky Way and Andromeda, are falling toward each other. They are being drawn together by their mutual, irresistible gravitational embrace. Right now, as you sit here, the Andromeda galaxy is hurtling in our direction at a speed of over 100 kilometers per second. That's fast enough to travel from London to New York in under a minute. Every hour it gets almost 500,000 kilometers closer. This is not a theoretical calculation. It is an observed fact, a destiny written in the color of starlight. We are on a collision course. In about 4.5 billion years, our two majestic spiral galaxies will meet. This event will not be an explosion in the traditional sense. A galactic collision is a far stranger and more elegant affair. Space is by its very nature mostly empty. Even within a galaxy, the stars themselves are incredibly far apart. The chances of any two individual stars actually crashing into one another are infinitesimally small. So this will not be a demolition derby of suns, it will be a merger, a metamorphosis, a gravitational encounter of unimaginable grace and violence. Imagine the view from a planet in the far future orbiting a sun much like our own. For millions of years, the Andromeda galaxy would have grown in the night sky. What was once a faint fuzzy patch of light would become a brilliant, sprawling disk, eventually rivaling the arc of the Milky Way itself. Two majestic rivers of starlight would dominate the heavens, a celestial spectacle beyond our wildest dreams. Then, as the two galaxies begin to interpenetrate, their structures will be warped and destroyed. Their beautiful, delicate spiral arms will be twisted and flung aside by colossal gravitational tides. Vast streamers of stars and gas, hundreds of thousands of light-years long, will be ejected into intergalactic space, creating ghostly tidal tails. The two galactic disks will pass through each other, like phantom fleets, the individual stars sailing past one another, unharmed. But the gas clouds, the vast interstellar nebulae, will not be so lucky. They will slam into each other with ferocious energy. This colossal shockwave will trigger a firestorm of star formation. The merging galaxies will light up with the brilliant blue light of millions of newborn massive stars, a period of intense, brilliant creation born from an act of cosmic destruction. The night sky would be ablaze with the light of this starburst, a celestial renaissance of epic proportions. And at the heart of this titanic event, the two supermassive black holes will begin their own final fateful dance. Sagittarius A star, our 4 million solar mass behemoth, will find its counterpart, Andromeda's central black hole, a truly monstrous entity weighing over 100 million solar masses. Locked in a gravitational grip, they will begin to orbit one another, spiraling closer and closer over millions of years. They will shed vast amounts of energy, not as light, but as ripples in the fabric of space-time itself. Gravitational waves pulsing outward at the speed of light will carry the news of this cosmic wedding across the universe. Finally, they will merge. In a fraction of a second, two of the most powerful objects in our corner of the cosmos will become one. The resulting cataclysm will release more energy than all the stars in both galaxies combined, a silent thunderclap that shakes the very foundations of reality. Out of the chaos and debris of two spiral galaxies, a new entity will be born, a single gigantic elliptical galaxy, a vast roundish swarm of stars, its glory days of star formation now behind it. Astronomers have already given it a name, Milkomeda, or sometimes the less elegant Milkdromeda. This is the ultimate fate of our home. Our destiny is not to drift alone, but to merge to become part of something larger. This impending collision redefines everything we thought we knew about our place. The motion of our sun around Sagittarius A star is not the final story. The motion of Sagittarius A star within the swirling local group is not the final story. The defining motion, the primary vector of our entire galaxy, is this inexorable fall toward Andromeda. Our supermassive black hole is not an anchor. It is the heart of a ship that is already underway on its final voyage. It is being pulled, dragged, and accelerated through the cosmos toward a dramatic, predetermined rendezvous. So have we found our answer? If everything in the Milky Way orbits Sagittarius A star, what does Sagittarius A star orbit? Does it orbit the common center of mass between itself and the Andromeda galaxy? The barycenter of the coming merger is that the ultimate gravitational allegiance, the final destination on our cosmic map. It is a tidy, compelling answer. It frames our existence within the story of our local family, a drama playing out over billions of years. But the universe is rarely so simple. The cosmos is a nested hierarchy of structures, a Russian doll of gravitational influence, each layer larger and more massive than the last. And the moment we begin to feel we have found the ultimate frame of reference, the universe reveals another grander scale of motion. Because the local group, our entire galactic family, is not an island either. This whole chaotic cluster of more than 50 galaxies, all swirling and merging, is itself a passenger. Our entire neighborhood, locked in its internal struggles, is being pulled by an even greater, more mysterious force. We have been tracking the motion of a single ship, only to realize that the ocean itself is flowing. Our journey toward Andromeda is just one leg of a much larger, much faster, and much more mysterious voyage. We are moving, all of us together, towards something unseen, something vast, something that lies out there in the darkness beyond the borders of our galactic home. The investigation must go deeper. The scale must expand once more. For if our entire galactic family is hurtling through the void, what is the invisible hand guiding us? Where are we all going? We have been asking the wrong question. The entire journey to the heart of our galaxy, this pilgrimage to the edge of an event horizon, was built on a simple, elegant, and ancient idea. The idea of the orbit, the moon around the Earth around the sun around the core of the Milky Way. It is a cosmic clockwork, a dance of nested circles, predictable, tidy. Reassuring. So we asked, what does our galaxy's anchor orbit? What grander sun does Sagittarius A star circle? We searched for a center, a focal point, an even more monstrous black hole in the void. We assumed the universe played by these familiar rules. But the cosmos on its grandest scales is not a clock. It is a river. And the answer to our question is not a place or a thing. It is a direction, a flow, a fall. To understand the true journey of our galactic core, we must first zoom out, far beyond the spiral arms of the Milky Way, past our neighbor Andromeda, past the local group of galaxies, out and out until entire galaxies are just motes of dust glittering in an unfathomable darkness. From this vantage point, we can finally perceive the most fundamental motion in the universe. It is a motion that is happening to you right now. It is carrying you away from nearly everything you see. It is not a journey through space, but a journey of space. The very fabric of reality is stretching, expanding, carrying clusters of galaxies away from each other like raisins in a rising loaf of cosmic bread. This is the Hubble flow, the great cosmic tide. The universe's foundational breath, an exhalation that began 13.8 billion years ago and has never ever stopped. This is the baseline, the primary directive of cosmic motion. If nothing else were acting upon us, our Milky Way and Sagittarius A star within it would simply be carried along this majestic, expanding current. Our journey would be a simple, straight line outward drifting ever farther from our cosmic neighbors, a placid, predictable, and ever lonelier voyage. But that is not what is happening. The universe, it turns out, is not so placid. It is lumpy, it is messy, it is alive with gravity. When astronomers first began to map this cosmic expansion, they expected to see a uniform, elegant pattern. And for the most part they did. The farther a galaxy was, the faster it receded. It was a law written into the fabric of space-time. But as our instruments grew more sensitive and our maps of the heavens more detailed, we began to notice discrepancies. We found rebels, galaxies that were not quite behaving as they should. Some were moving away from us slightly slower than expected, others slightly faster, and some, against all logic of an expanding universe, were even moving sideways relative to the cosmic flow. They were like leaves caught in a vast, invisible wind, a wind that was blowing in a different direction from the river's main current. These deviations were not random, they were organized, coherent. Entire clusters of galaxies, vast swarms of stars, seemed to be acting in concert, as if responding to a silent, unseen conductor. They possessed what scientists call a peculiar velocity. A peculiar velocity is a motion independent of the Hubble flow. It is an extra push, an additional tug, a private journey superimposed on the public expansion. It is the signature of a local gravitational disturbance. It's the eddy in the river, the whirlpool that pulls you aside, disrupting your smooth passage downstream. And when we pointed our instruments back at ourselves, when we measured the motion of our own Milky Way, we discovered something astonishing. We have one of the most significant peculiar velocities known. We are not merely drifting, we are hurtling. Our entire galaxy, 100 billion suns, and the supermassive black hole reigning at its center are being pulled, compelled, shepherded across the cosmos at an almost incomprehensible speed, over 2 million kilometers per hour, a speed so immense it defies easy analogy. This is not a gentle drift, this is a headlong plunge. The cosmic river for us has a powerful local current, and it is dragging us towards something we cannot see. The hunt was on. What could possibly exert such a colossal gravitational pull? What unseen titan could command the allegiance of not just our galaxy, but our entire local group, and dozens of other galaxy clusters around us, all streaming in the same general direction? The problem was, when astronomers looked, they saw nothing. Nothing on the scale required to explain this motion. There was no supergalaxy, no impossibly vast object, no single gravitational anchor in the direction of our fall. Worse still, the direction of this mysterious pull pointed directly toward one of the most frustratingly opaque regions of our night sky, a band of darkness known as the zone of avoidance. This is not a true void. It is a blind spot created by our own galaxy. When we look toward it, we are trying to peer through the dense plane of the Milky Way's disk, a smog of countless stars, thick dust clouds, and glowing gas that blocks the light from whatever lies beyond. It's like trying to spot a distant mountain range while standing in the heart of a blinding blizzard. The very thing we sought was hidden behind our own home. For decades, this cosmic crime scene was obscured. The evidence of the pull was undeniable. The motion was measured, confirmed, and reconfirmed, but the culprit remained a phantom, a gravitational ghost. We knew we were falling, but we did not know what we were falling into. It took new eyes, new ways of seeing to pierce that veil. Not with visible light, which the dust easily absorbs, but with longer wavelengths like radio and infrared that could slip through the galactic fog. Slowly, painstakingly, astronomers began to map the hidden universe behind the zone of avoidance, and what they found defied all expectation. There was no single object. There was no one thing responsible for the pull. Instead, they uncovered something far stranger and far more profound. A vast, sprawling and diffuse concentration of mass. A region of space hundreds of millions of light-years across, where the density of galaxies was significantly higher than average. It was not a point, but a place. Not a singularity, but a sprawling gravitational basin. A valley in the landscape of space-time itself. They called it the Great Attractor, a name that evokes a sense of monstrous power of a singular devouring entity. But the reality is more subtle and in many ways more awesome. The Great Attractor is a convergence. It is the combined gravitational influence of thousands of galaxies, all bound together with immense halos of invisible dark matter. It is a cosmic watershed, a region where the gentle slopes of gravity all conspire to funnel matter in one direction. It is less a predator and more a destination. An overdensity of matter so profound that its gravitational whisper carries across unimaginable distances, tugging on our galaxy and countless others. So Sagittarius A* is not orbiting this entity. Orbit implies a stable repeating path around a central body. What our galaxy is doing is far more primal. It is simply falling. Along with our neighbours in the Virgo supercluster, we are on a one-way trajectory, a long, drawn-out descent toward this immense concentration of matter and energy. The journey of our galaxy's core is not a circle. It is a line, a vector, a submission to a deeper gravity. A gravity not of a single object, but of a sprawling collective. The mystery seemed solved. We were falling toward the Great Attractor. But the universe is a tapestry of nested secrets. Pull on one thread, and you will find it woven into another and another and another still. As our maps of the cosmos became even more sophisticated, we began to trace the motions of galaxies on an even grander scale. We discovered that the Great Attractor, this titan of gravity, was not the final destination. It was merely a way station, a local landmark. Because the Great Attractor itself is moving, it too is falling. This revelation shattered our perspective once again. It's like discovering the river you are floating on is itself flowing into an even larger sea. By mapping the peculiar velocities of tens of thousands of galaxies, astronomers could begin to chart the gravitational topography of our entire corner of the universe. They could draw the lines of cosmic flow, identifying the gravitational divides and basins that shepherd galaxies on their long journeys. What they unveiled was a structure of such breathtaking scale that it redefines our very concept of home. It is called Lania, a Hawaiian name meaning immeasurable heaven, and it is worthy of the title. Lania is a supercluster of galaxies, our supercluster, but it is defined not just by the galaxies it contains, but by the direction they are all flowing. Imagine a continental watershed on Earth. Every drop of rain that falls within its boundaries will eventually flow toward a single common basin. Lania is the cosmic equivalent. It is a domain of gravity, a superstructure 500 million light-years in diameter, containing 100,000 galaxies, just like our own. And every single one of them, every star, every planet, every speck of dust within this colossal structure is flowing inward. The great attractor is not some external alien object. It is the center of our own home. It is the bottom of our gravitational valley. The Milky Way, Andromeda, the Virgo cluster, all of the familiar cosmic landmarks we know are just different streams and tributaries in this one vast system, all headed for the same destination. Our headlong plunge across the cosmos is not an anomaly. It is our nature. It is the defining motion of our cosmic continent. We are not being pulled by a distant monster. We are simply following the contours of the space-time we inhabit. Sagittarius A star, our galaxy's heart, is a passenger on a vessel called the Milky Way. And the Milky Way is a droplet in a cosmic river, a river that is Lania. Its currents are dictated by the unseen distribution of dark matter, the ghostly architecture that forms the bedrock of the universe. We flow along filaments of this invisible scaffold drawn from the cosmic voids where matter is scarce and funneled into the dense knots and junctions where galaxies cluster. And even this immeasurable heaven is not the end. When we look at the flow of Lania itself, we see that our entire supercluster is also in motion, being drawn toward an even more massive concentration of galaxies, a distant behemoth known as the Shapley supercluster. It is a gravitational hierarchy stretching out to the limits of our vision, flows within flows, structures within structures, a universe that is not static but dynamic and interconnected, where everything is in the process of becoming, of moving, of falling. So we return at last to our central question. What does Sagittarius A star orbit? The answer is now so profoundly different from where we began. It orbits nothing, because the very concept of a simple orbit has dissolved. It has been replaced by a richer, more complex, and far more magnificent truth. Sagittarius A star is a participant in a grand cosmic migration. It is caught in a gravitational cascade. It is a follower of a current set in motion by the birth of the universe, shaped by the lumpy, imperfect distribution of the first matter, and guided by a dark, invisible scaffold we are only beginning to map. Its journey is not a closed loop, but an open-ended fall. A fall through the local group of galaxies, a fall toward the Virgo cluster, a fall that is part of a larger flow toward the great attractor, a flow that defines our home, the Lania supercluster, a home that is itself falling towards something even greater still. We have been looking for a center, a point of stillness, but the universe has shown us there may be no such thing. There is only the journey. A journey shared by every star in our sky, every planet we have ever discovered, and by you right now. A silent, relentless, and extraordinary fall through the heavens. We have found a direction, a faint gravitational arrow pointing us toward a destination in the cosmic ocean. Our Milky Way with Sagittarius A as its heart is not adrift but on a pilgrimage. A journey toward a colossal convergence of mass, a great attractor pulling us from across the void. But to know your destination is one thing. To measure your own movement across such an abyss, to chart your speed and trajectory through infinity, is a challenge of an entirely different order of magnitude. It is a problem of profound and maddening relativity. How do you measure the speed of your own ship when the entire ocean is flowing along with you? When the lighthouses you use for navigation are themselves on vessels carried by the same current? There is no fixed point, no cosmic shoreline to reference. Every star, every galaxy, every cluster we can see is also a passenger on this great unfolding journey. We are all falling together. This is where the grand, heroic story of astrophysics slows to a crawl, becoming a tale of quiet patience. It transforms into the sleepy scientist stories. These are not narratives of sudden explosive discovery of a single eureka moment that changes everything overnight. These are epics of endurance. They are chronicles written in the faint light of distant galaxies, collected one photon at a time over decades. They are the stories of astronomers growing old in quiet observatories, staring at screens that display infinitesimal shifts in starlight. Imagine a cartographer tasked with mapping a continent, but they can only take one measurement every 10 years. And with each measurement, they must account for the fact that the continent itself is drifting, the mountains are eroding, and the rivers are carving new paths. Now, scale that problem up to the size of the observable universe. This is the colossal task facing the architects of our cosmic maps. They are not merely observing the cosmos. They are trying to distill motion from a universe where everything is in perpetual flowing motion. Their primary tool is the light from bygone eras, light that has traveled for hundreds of millions, even billions of years to finally reach our telescopes on Earth. This ancient light is a messenger carrying a secret in its spectrum. As it journeys across an expanding universe, the very fabric of space it travels through stretches, and as space stretches, the light wave itself is stretched along with it. Its wavelength elongates, shifting toward the red end of the spectrum. This is the cosmic redshift. It is the universe's own signature of expansion, the Doppler effect written on a cosmological scale. The greater the distance, the more the light has been stretched, the more profound its journey toward red. By meticulously measuring this redshift for countless galaxies, astronomers can build a three-dimensional map. They can see not just where a galaxy is in the sky, but how far away it is in the unfathomable depths of space and time. It is a form of celestial archaeology. We are plotting the ruins of ancient light to reconstruct the present. For generations, astronomers have been engaged in this painstaking work. Vast surveys with names like the Sloan Digital Sky Survey have spent years systematically scanning the heavens. Automated telescopes awaken each night, methodically pointing, capturing, and cataloguing. Each data point is a single galaxy's redshift, a single clue. Slowly, painstakingly, a picture begins to emerge from the noise, a tapestry woven from millions of points of light. This is the large-scale structure of the universe. But this map reveals a complication that is both beautiful and terrifying. The galaxies are not distributed randomly like dust sprinkled in a box. They are organized. They trace luminous, thread-like structures called filaments, stretching for hundreds of millions of light years. These filaments connect at dense, brilliant intersections, great clusters of galaxies, cosmic cities blazing with starlight. And between these shimmering filaments lie the great voids, immense dark bubbles of near-total emptiness regions where the universe seems to be holding its breath. We live within this cosmic web. Our Milky Way is a single speck of light on one of these filaments, and our motion is not a simple flight through empty space. It is a flow, a cascade along these preordained channels. We are being guided by a gravitational topography we are only just beginning to map. We are sliding down a gentle cosmic valley carved by the combined gravity of everything on our filament, drawn toward the great metropolitan cluster that lies ahead. So the sleepy scientists had a map and a theory. Our galaxy is moving, flowing, along with its neighbors toward a nexus of greater mass. We can measure the redshift of galaxies ahead of us and compare them to the redshift of those behind us. This should reveal a subtle pattern, a dipole, a slight blue shifting in our direction of travel, and a slight red shifting from the direction we leave behind. The cosmic microwave background radiation, the afterglow of the Big Bang, should hold a similar secret, a faint temperature asymmetry imprinted by our motion through its ancient light. The measurements were made, the data collected over years, and the pattern was there. It was undeniable. The Milky Way is moving at a staggering 600 kilometers per second relative to the cosmic background, a velocity of over 1,000,000 miles per hour. Our entire local group of galaxies, a caravan in the dark, is hurtling through intergalactic space. The map seemed to work. The trajectory could be plotted. The destination, the great attractor, seemed confirmed. But just as this cosmic narrative was solidifying, a ghost appeared in the machine. The story began not in the vastness of intergalactic space, but in the elegant spirals of individual galaxies. Astronomers like Vera Rubin, studying how galaxies spin, found something that should have been impossible. According to everything we knew about gravity and matter, the stars on the outer edges of a spiral galaxy should move much more slowly than the stars near the center. Just as Pluto ambles through its orbit while Mercury zips around the Sun, gravity's grip weakens with distance. It is a fundamental rule, but when they measured the speeds, the rule was broken. The stars on the periphery were moving just as fast in some cases, even faster than the stars in the core. It was as if some unseen hand was holding the galaxies together. They were spinning so fast they should have flown apart, flinging their stars into the intergalactic darkness. But they did not. They remained stable, coherent, impossibly swift. The implication was as clear as it was shattering. There had to be more matter in these galaxies than we could see, vastly more. It was not just a little bit of missing mass. The calculations suggested that the stars, the gas, the dust, everything luminous and familiar that we call a galaxy, accounted for only about 15% of the required mass. The other 85% was something else, something that did not shine or reflect or absorb light, something that felt the pull of gravity, but otherwise remained utterly perfectly invisible. They called it dark matter. This discovery was not a minor correction to our models. It was a paradigm shift of monumental proportions. It was like a biologist realizing that for every visible creature on Earth, there were 5 invisible ones, shaping the ecosystem. Suddenly, our cosmic map, so carefully constructed from points of light, seemed like a fraud. We had been mapping only the lighthouses, while ignoring the existence of the continent they were built on. We had charted the glowing sea foam and missed the entire invisible ocean underneath. This phantom substance, this dark matter, isn't just in galaxies. It is the universe. It forms a vast, invisible scaffolding upon which everything else is built. The shimmering filaments of the cosmic web traced by galaxies. They are just the visible component, the luminous frost decorating a much larger, unseen structure of dark matter. The great voids are not just empty of light, they are primarily empty of this dark material as well. The galaxies themselves exist as mere condensations, luminous puddles settled into the deepest wells of an immense invisible gravitational landscape. This changes everything about the journey of Sagittarius A. Our black hole and our Milky Way are not just being pulled by the visible light of the Virgo supercluster or the great attractor. That is only a fraction of the story. We are being guided, shepherded, and drawn onward by colossal halos of dark matter that surround those structures. Our motion is a response to an unseen architecture. We are flowing through a universe where the dominant gravitational force is exerted by a substance we cannot see and do not understand. It is a cosmic haunting. Measuring our trajectory becomes exponentially more difficult. It is like trying to navigate a river in the dead of night. We can see the faint lights of towns along the bank, but we cannot see the riverbed itself. We are unaware of the deep channels, the hidden sandbars, the powerful unseen currents that are truly dictating our path. The sleepy scientists must now account for this gravitational ghost. They must infer its presence, model its distribution, and calculate its influence without ever observing it directly. It is a process of mapping a phantom world. They look for its fingerprints, its gravitational shadow. They observe how the light from distant quasars is bent and distorted as it passes through a foreground galaxy cluster. The amount of bending this gravitational lensing reveals the true mass of the cluster, light and dark combined. The result is always the same. The ghost is there. The invisible mass outweighs the visible by an enormous margin. The cosmic web is not a web of light. It is a web of darkness, merely decorated with stars. So our pilgrimage is not toward a city of light. It is toward a concentration of this profound cosmic mystery. Sagittarius A is falling, but it is falling through a gravitational field dominated by a substance unknown to all of human science. This realization alone was enough to humble generations of astronomers. It placed a fundamental veil between us and the true nature of reality. But as the maps became more refined, as the measurements became more precise, the universe revealed that it was hiding not one ghost but two. And the second was even more bewildering than the first. As cosmologists refined their models of the universe, a grand narrative had taken hold. The universe was born in the fire of the Big Bang and has been expanding and cooling ever since. The mutual gravitational attraction of all the matter within it, both light and dark, should be acting as a brake. The expansion should be slowing down. The ultimate fate of the universe depended on this cosmic battle between the outward momentum of the initial expansion and the inward pull of gravity. Would the universe slow to a halt and collapse back in on itself, or would it slow down forever, coasting into a cold, dark eternity? To answer this, astronomers needed a standard candle, something of a known, consistent brightness that could be seen across billions of light years. If you know how bright something truly is, you can determine its distance by how dim it appears. They found their candle in a specific type of stellar explosion, a type Ia supernova. These cataclysms occur when a white dwarf star accumulates a precise amount of matter, pushing it over a critical limit. The result is a thermonuclear detonation of astonishing and, more importantly, predictable brilliance. Two independent teams of astronomers set out on a grand quest. They would hunt for these distant, fleeting explosions in the farthest reaches of the cosmos. By measuring their redshift and their apparent brightness, they could chart the expansion history of the universe. They could measure precisely how much gravity had slowed things down over the eons. It was another sleepy scientist story in the making. Years of scanning the sky, waiting for a distant galaxy to suddenly flare with the light of a dying star. It was painstaking, meticulous, and profoundly important work. And in the late 1990 seconds, the results came in. Both teams working independently found the same thing. Something so bizarre, so contrary to all expectation, that they assumed their data must be wrong. They checked their calculations. They recalibrated their instruments. They searched for any possible error that could explain the anomaly. But the conclusion was inescapable. The distant supernovae were dimmer than they should have been. They were farther away than the prevailing models predicted. The expansion of the universe was not slowing down. It was speeding up. This was not just a surprising result. It was nonsensical. It was like throwing a ball into the air and watching it accelerate upward into the sky faster and faster. Something was actively pushing the universe apart. Some mysterious, repulsive force inherent to the fabric of space itself was overwhelming the collective gravity of all the matter in the cosmos. This force, this energy, was given a simple yet profoundly empty name: dark energy. It was the second ghost. If dark matter is the invisible scaffolding pulling things together, dark energy is the invisible wind tearing them apart. It is a cosmic headwind, a pressure that permeates all of space, causing the universe to expand at an ever-increasing rate. Its existence fundamentally alters the nature of our cosmic journey. It means the river we are flowing down is not just invisible, it is also widening and accelerating as we travel. The very space between our Milky Way and our destination is stretching, expanding, fighting against our forward motion. Think of our pilgrimage toward the great attractor. We are being pulled by the gravity of that immense supercluster. But at the same time, the dark energy in the space between us is creating more space, pushing the great attractor away from us. It is a cosmic tug-of-war on the grandest possible scale. On relatively local scales, like within our supercluster, the gravitational pull of dark matter still wins. Gravity can hold galaxies and clusters together against this push. But on the largest scales across the great voids, dark energy dominates. It is driving clusters apart, isolating them in an ever-expanding emptiness. Our journey is now a complex dance of competing infinities. We are caught in a gravitational current, a flow along the cosmic web pulled by the phantom mass of dark matter halos. This current carries us toward the dense nodes of the web, the great cities of galaxies. But the entire web itself is being stretched and unraveled by the pervasive, repulsive force of dark energy. The path of Sagittarius A is therefore not a simple orbit. It's not even a simple fall. It is a drift, a slide, and a struggle all at once. We are flowing toward a point of convergence, while the universe itself conspires to make that journey longer. The goalposts are moving. The sleepy scientists, in their quest to map our motion, must now contend with a universe that is not just complex, but actively working against their efforts to understand it. They must factor in the invisible pull of one ghost and the invisible push of another. Their models must account for a cosmos where 95% of its content is entirely unknown. This is the formidable reality of our place in the cosmos. Sagittarius A, our galaxy's anchor, is a passenger on a vessel shaped by forces beyond our comprehension. Its path is a whisper of a trajectory drawn between the competing influences of cosmic ghosts. It is an impossibly subtle dance choreographed by the unknown. And to map this dance, to understand this flow, is to attempt to read the mind of the universe itself, a mind that appears from our limited perspective to be profoundly, beautifully, and terrifyingly dark. We have been asking the wrong question. All this time we have searched for a single celestial throne, a gravitational monarch so immense that even our galaxy's heart, our supermassive black hole, must bow and circle in deference. We sought a definitive center, a fixed point on a cosmic map. This search, this very natural, very human instinct to find a center, was based on a misunderstanding of the universe's true nature. The answer to what Sagittarius A orbits is not an object. It is not a place. It is a journey, a trajectory, a fall. To understand this fall, we must first pull our perspective back far beyond the spiral arms of the Milky Way, until our brilliant home is just one luminous pinwheel among a gathering of others. We find ourselves in what we call the local group. It is not so much a group as it is a small, gravitationally intimate consortium of more than 80 galaxies all bound together. This is our immediate cosmic family, a clan held in a delicate, complex dance that has lasted for billions of years. Most members of this family are small, faint dwarf galaxies orbiting the two dominant patriarchs of the group, our own Milky Way and the magnificent Andromeda galaxy. For eons, these two titans have been circling one another, two gravitational leviathans in a slow, inexorable embrace. Every star you see, every planet in our galaxy, and Sagittarius A itself, is a passenger in this grand, gravitationally dictated waltz. So the first part of our black hole's motion is not an orbit, but a shared movement, a collective drift within this local system. Andromeda is not just a pretty smudge of light in our night sky, it is our destiny. It is hurtling towards us at a staggering 110 kilometers per second. 4.5 billion years from now, our two galaxies will collide. They will merge their stars, passing through one another like ghosts, but their central black holes will eventually find each other. Sagittarius A and its Andromeda counterpart will engage in a final, violent spiral, shedding gravitational waves until they become one, forming a new, even more massive black hole at the heart of a giant elliptical galaxy. Some have already named Milky Way. So you see, the motion of Sagittarius A is already deeply complex part of a shared trajectory with our galactic neighbors, a story of an eventual spectacular union. It is traveling with its family. But this family is not stationary. The entire local group, this entire island of galaxies, is on a voyage of its own. If we zoom out further still, the local group shrinks into a tiny, almost insignificant cluster, and we begin to see that it is moving, and moving with purpose through the vast emptiness of intergalactic space. What could possibly be powerful enough to command the movement of an entire family of galaxies, including two massive ones? The answer lies in the direction of the constellation Virgo. There, some 54 million light-years away, lies a monster, the Virgo supercluster. This is not merely a group, it is a sprawling, incandescent metropolis of galaxies. It contains over 1,000, perhaps 2,000 distinct galaxies, all swarming around a dense, chaotic core dominated by giants, like the colossal elliptical galaxy Messier 87. Its gravitational influence is the defining feature of our cosmic neighborhood. It is the great basin towards which all local rivers of galaxies flow. Our local group, our small clan, is on the distant outskirts of this megacity, but we feel its pull. We are undeniably, irrevocably part of its dominion. We are falling towards it. The entire local group, carrying the Milky Way and Sagittarius A with it, is being drawn toward the heart of the Virgo supercluster. This journey adds another vector, another layer to our black hole's path. It is not a simple orbit, but a long, graceful, determined infall, a pilgrimage across millions of light years towards a greater center of mass. For a long time, astronomers believed this was the final answer, that we were all just suburbs of the great Virgo downtown, that our ultimate fate was to be assimilated into its bustling core. But then we began to map the universe on even grander scales, and we discovered that the rules of the road were far stranger, and the map itself was unlike anything we had ever imagined. To truly grasp the path of Sagittarius A, you must abandon the idea of galaxies scattered like dust motes in a void. That picture is profoundly, fundamentally wrong. The universe on its largest scales has a structure, a breathtaking, ethereal, and utterly gigantic architecture. We call it the cosmic web. Imagine filaments of unimaginable length, threads spun from dark matter, laced with glowing galaxies like dewdrops on a spider's silk. These filaments stretch for hundreds of millions of light years, connecting massive hubs where galaxies cluster together in dense knots. These are the superclusters, the blazing intersections of the cosmic highway. Between these luminous threads and brilliant nodes lie the voids, immense, terrifyingly empty chasms of near-perfect nothingness, some so large that our entire supercluster could fit inside them. These are the great cosmic deserts where matter is scarce and the silence of the universe is at its most profound. This is the true landscape of the cosmos, not a random scattering, but a delicate sponge-like structure, a scaffolding of creation where gravity has woven matter into a celestial tapestry of breathtaking scale and complexity. Our galaxy, our local group, our Virgo supercluster, we are not isolated islands. We are all embedded within this web. Our motion is not a simple flight through empty space. It is a journey along the contours of this cosmic structure, like a bead sliding along a string. Galaxies and clusters flow along these filaments, draining from the empty voids and streaming towards the dense hubs pulled by the collective gravity of the web itself. This revelation changed everything. It showed us that our motion was not just a fall towards Virgo. Virgo itself was also moving. The entire supercluster, our home, was just one part of a much larger, more coherent flow, a river of galaxies coursing through the cosmos. And a river must flow somewhere. By meticulously charting the velocities of tens of thousands of galaxies, astronomers made a discovery that redrew our cosmic address. They found that our Virgo supercluster is just a peripheral lobe, an outlying province of an even more colossal structure. A basin of attraction so vast it contains 100,000 galaxies. They gave it a name taken from Hawaiian for the immensity it represents, Lania, immeasurable heaven. Lania is our home supercluster. It is one of the largest known structures in the universe, but it is not a structure you can see with your eyes. It has no clear edge, no physical boundary. Its borders are defined by gravity, by motion. Imagine a vast watershed on Earth, a continental divide. Every drop of rain that falls on one side of the line will inevitably flow into one specific ocean basin. Lania is a gravitational watershed. Every galaxy within its boundary, including our own, is flowing downhill towards a common center of gravity. Our fall towards Virgo is merely a local current in this immense river. Virgo, us, and thousands of other galaxy groups are all part of a single coordinated flow, a grand confluence of matter streaming towards the deepest part of this gravitational valley. So where is this river taking us? What lies at the bottom of the Lania basin? Here the mystery deepens because the heart of this great flow is something we struggled to see for decades. It is a place that lies in the direction of the constellations Centaurus and Norma, a region of space obscured by the dense gas and dust of our own Milky Way, a zone of avoidance where our view is frustratingly blocked. For years, astronomers knew something was out there. They could measure its effects. They saw a great anomaly in the cosmic flow. Galaxies in our part of the universe, over a region spanning hundreds of millions of light years, were all being pulled by a force that defied simple explanation. They were moving faster than they should, drawn by an unseen hand. They called this gravitational mystery the Great Attractor. It is not a single object. It is not a supermassive black hole. It is an immense concentration of mass, a gravitational anomaly, a region where the filaments of the cosmic web have converged, creating a density peak, a great basin in the fabric of spacetime. It is the lowest point in our local universe, the drain at the bottom of the Lania watershed, and we are circling it. This is the ultimate answer to our question. Let us trace the path, your path, through the cosmos. Right now you are sitting still, yet you are orbiting Earth's center. The Earth is hurtling around the Sunday. The Sun is orbiting the galactic core, our Sagittarius A. And Sagittarius A, it is not orbiting a thing. It is executing a fall. It falls with the Milky Way in the gravitational dance of the local group. The entire local group falls towards the heart of the Virgo supercluster. The entire Virgo supercluster is just one stream in the immense flow that defines our home, the Lania supercluster. And this entire colossal structure, this immeasurable heaven, is draining, flowing, streaming, and falling towards the deepest gravity well in our corner of existence. A diffuse, mysterious, and powerful concentration of matter we call the Great Attractor. Our black hole's orbit is a continuous, directed, multi-leveled fall through the very architecture of the universe itself. It is a passenger on a journey dictated by gravity on every scale, from the dance of local galaxies to the continental drift of superclusters. It is a motion guided by invisible filaments of dark matter, a path that follows the grandest currents of the cosmic ocean. The feeling of stillness you have at this moment is a profound illusion, a quiet pause on a vessel that is part of an unbroken cascade. A cascade that began with the Big Bang itself. We are not in a static clockwork cosmos of simple orbits. We are in a dynamic, flowing, evolving universe, and its heart, Sagittarius A, is not a fixed anchor. It is a fellow traveler swept along with us on the same cosmic tide, on a one-way voyage towards a future we can only begin to comprehend. A journey whose final destination remains the greatest mystery of all: undefined. Our journey began with a question simple in its phrasing yet profound in its implications. We looked to the heart of our own galaxy, to the gravitational sovereign enthroned in darkness, to Sagittarius A star, the supermassive black hole around which everything we know revolves. We saw a celestial kingdom of 200 billion suns, all held in a delicate spinning embrace. And we asked if this is our anchor, our center, our pivot point. What does the anchor orbit? It felt like a search for a final fixed point in the cosmos. A search for an ultimate foundation upon which our own existence is built. We have traveled far since asking that question. We have journeyed from the glowing heart of the Milky Way out into the chilling void between the galaxies, and the answer we found is not what we expected. It is so much grander, more complex, and infinitely more humbling. The universe we have discovered has no stationary thrones. There are no final anchors. There is only the dance. Let us retrace our steps one last time, not as a review, but as a final breathtaking ascent in perspective. We started with the familiar, the galactic metropolis we call home. Here, Sagittarius A star appears as the undisputed ruler. Its 4 million solar masses of compressed reality dictate the graceful arcs of nearby stars. Its influence extends across 100,000 light-years, choreographing the spiral arms. It is the silent, invisible conductor of our galactic orchestra. From our vantage point, its authority seems absolute, its position unassailable. Yet even here within its own domain, the monarch is not still. Our galaxy is not a rigid spinning disk like some celestial machine. It is a fluid, dynamic living system. Sagittarius A star is subtly jostled by the gravitational chatter of globular clusters. It is nudged by the passage of colossal clouds of gas and dust. It sways and drifts within the galactic core, a monarch walking the floors of its own castle. It is a slow, almost imperceptible motion, but it is the first clue, the first hint that absolute stillness is an illusion in our universe. This was the first crack in our conception of a fixed galactic heart. But to truly understand its journey, we had to pull back to see our galaxy not as a universe, but as an island. We ascended, leaving the glowing spiral of the Milky Way behind us. It shrank in our view from a sprawling city of light to a single luminous pinwheel. And in the darkness, another, even larger, came into view. Andromeda. Our sister galaxy, our cosmic neighbor, our gravitational partner, in an immense and ancient waltz. For billions of years, these two colossal structures have been locked in an invisible embrace. They are falling towards each other, drawn by a mutual attraction that spans millions of light years. This is the next level of the hierarchy, the next layer of motion. Sagittarius A star is not just drifting within the Milky Way's core. The entire Milky Way, with Sagittarius A star embedded within it, is moving. It is hurtling through the intergalactic void at over 100 kilometers every single second. It is a participant in a majestic slow-motion collision course, a gravitational destiny set in motion at the dawn of time. This is not an orbit in the classical sense, not a neat, repeatable loop. It is a one-way journey, a cosmic merger in the making. Our galaxy's black hole is being pulled relentlessly towards the heart of another. This realization shattered the idea of our galaxy as a solitary empire. We are part of a duo, a binary system of immense proportions, a member of what astronomers call the local group, a small cluster of dozens of galaxies all gravitationally intertwined. and the entire local group, this small neighborhood of islands, is itself in motion. It is a caravan traveling together through an even greater wilderness. To see where this caravan was headed, we had to pull back again, farther and farther, until our local group became just a tiny smudge of light, and we found ourselves in a new territory, a structure of staggering scale and population, the Virgo supercluster. Imagine a sprawling archipelago containing over 100 galactic groups and clusters, a celestial kingdom stretching 110 million light-years across, and at its heart a monstrous concentration of mass, the Virgo cluster. Here, thousands of galaxies are swarmed together in a chaotic, incandescent swarm. Their combined gravitational power is immense, a well of space-time that dominates our entire cosmic region. For a long time, we thought this was the answer. We believed our local group, our caravan, was simply falling towards this immense galactic metropolis. It made perfect sense. The Virgo cluster was the biggest thing around. It was the great city on the hill, so we reasoned everything must be flowing towards it. Sagittarius A star, carried within the Milky Way, which is carried within the local group, was on a path to Virgo. This was the next orbit, the next level of fealty in the cosmic hierarchy. But science is a story of deeper and more subtle investigations. When we measured our motion with greater precision, we found a discrepancy, a cosmic anomaly. Yes, we were moving towards the Virgo cluster, but that was not the whole story. There was another component to our velocity, another direction, another pull. It was as if we were being swept along by a river, and while we were indeed flowing towards a large vortex nearby, the entire river itself was moving somewhere else entirely. Something else, something even larger and more massive than the Virgo cluster was pulling on us. But when we looked in that direction, we saw nothing special, no great concentration of galaxies, no brilliant beacon of light, just an ordinary patch of sky beyond the constellations of Hydra and Centaurus. Yet the evidence was undeniable. Our galaxy, the Andromeda galaxy, the Virgo cluster itself, and thousands of other galaxies around us were all being dragged sideways. They were all streaming in unison towards this enigmatic, unseen point in space. For decades, it was one of cosmology's greatest mysteries. It was given a name that speaks to its power and its secrecy, the Great Attractor, an unseen concentration of mass equivalent to tens of thousands of Milky Way galaxies. It was a gravitational anomaly so potent that its influence was warping the very fabric of our local universe. The search for the Great Attractor was a piece of cosmic detective work on the grandest scale. The problem was that it lay hidden, obscured, behind the dense plane of our own Milky Way galaxy. Our view was blocked by thick curtains of gas dust and the glare of billions of foreground stars. It was like trying to spot a distant mountain range while standing in the middle of a blindingly bright forest. We had to invent new ways of seeing. We built telescopes that could detect wavelengths of light that pass through the dust. We mapped the motions of countless galaxies, tracing their velocities, working backward from their movement to infer the source of the gravity. We became hydrographers of the cosmos, mapping flows and currents, not of water, but of galaxies. And what we discovered redefined our place in the universe once more. The Great Attractor was not a singular object. It was not some monster galaxy or an impossibly large black hole. It was something far more profound. It was the center, the gravitational heart of an even larger structure, a colossal filament of the cosmic web, a supercluster of superclusters, a structure so vast, so immense, that our own Virgo supercluster is just a minor suburb on its outskirts. They named it Lania, a Hawaiian name meaning immeasurable heaven, and it is a name that is truly earned. Lania is a celestial continent, 500 million light-years across. It contains the mass of 100 quadrillion suns, 100,000 large galaxies, including our own, are bound together within its gravitational basin. This was a revelation that fundamentally changed our cosmic map. The concept of a supercluster was no longer just a visual collection of galaxies in one part of the sky. It was now defined by motion, by a shared gravitational destiny. Think of it like a watershed on Earth. Rain that falls on one side of a mountain range will flow into one river system and one ocean. Rain that falls on the other side will flow to a completely different one. Lania is a cosmic watershed. Every galaxy within its boundaries, no matter how distant, is flowing downhill in space-time, flowing towards a common gravitational basin, a broad, flat valley in the center, and at the bottom of that valley lies the great attractor. Our galaxy, our home, is a single drop of water in this celestial river. Sagittarius A* is just a speck of dust carried within that drop. Its motion is not an orbit in any sense we would recognize. It is part of a grand cosmic flow, a pilgrimage of 100,000 galaxies, a journey towards the heart of our home supercluster. So is this it? Is this the final answer? Does Sagittarius A*, and by extension our entire galaxy, orbit the great attractor at the heart of Lania? For a moment it seemed like we had finally reached the end of the chain of command. But the universe is never so simple, because even a structure as monumental as Lania is not an island. It too is just one part of an even greater structure, the cosmic web. When we pull our perspective back for the final ultimate time, we see the universe for what it truly is. Not a void with scattered points of light, but a luminous, interconnected tapestry. It is a network of unimaginable scale, composed of immense filaments of galaxies and dark matter. These filaments stretch for billions of light years, weaving through the cosmos. They connect dense, brilliant nodes, which are the superclusters like Lania. And between these filaments lie the great cosmic voids, staggering expanses of near-total emptiness, hundreds of millions of light years across. This is the largest scale of structure that exists, and on this scale the story is not just about pulling, it is also about pushing. While the immense mass of the filaments and superclusters pulls galaxies towards them, the vast emptiness of the voids exerts a kind of opposite effect. These voids are so empty, so devoid of matter, that they have less gravitational pull than the universal average. Effectively, they push matter away. They are like high-pressure zones in a cosmic weather system repelling galaxies from their empty centers. And when we mapped our motion on this ultimate scale, we found the final crucial piece of the puzzle. Lania, our entire home supercluster, is not just flowing towards the great attractor, the entire continent is being pushed from behind. Astronomers have identified an enormous void located in the opposite direction of our motion. It has been named appropriately the dipole repeller. Our cosmic velocity, the precise speed and direction of our galaxy through space, is a vector. It is the sum of all the gravitational forces acting upon us from every scale. It is a combination of the pull from the Virgo cluster and the much greater pull from the great attractor region, and the immense pull from an even more distant concentration of mass called the Shapley concentration, and crucially the push from the dipole repeller behind us. So what does Sagittarius A* orbit? The answer is as beautifully complex as the universe itself. It orbits the combined center of mass of the Milky Way, but only loosely. That entire system is falling towards Andromeda. That binary system is being pulled towards the core of the Virgo cluster. That entire cluster is just one stream in the great river flowing towards Lania's heart. And that entire supercluster, that immeasurable heaven, is being simultaneously pulled by distant structures and pushed by colossal voids in the cosmic fabric. There is no single center. There is no simple orbit. There is only the sum total of everything. Our galaxy's motion is a response to the entire distribution of matter and energy in the observable universe. Every distant supercluster, every ghostly filament of dark matter, every vast and empty void, each one casts a gravitational vote, contributing a tiny tug or a subtle nudge. Sagittarius A star is on a journey dictated by the grand architecture of reality itself. It is a particle of dust caught in a cosmic hurricane, a storm whose scale is almost beyond our imagining. And in this revelation lies a profound humility. We began by looking for a foundation, a point of stability in a restless cosmos. We found instead that the universe is fundamentally irrepressibly dynamic. Everything from the smallest moon to the largest supercluster is in a state of perpetual motion. It is a universe not of destinations but of journeys, a cosmos not of fixed points but of currents, tides and flows. The very monarch of our galaxy, the object we thought of as our unmoving center, is just another traveler. It is a pilgrim on a path it cannot control, guided by the invisible hands of cosmic geography. This understanding does not diminish its power, but places it in a breathtaking new context. It shows us that even the mightiest entities are subject to still greater forces, that no matter how significant something seems from one perspective, it is part of a larger, interconnected whole. And our quest to understand this cosmic dance is far from over. The greatest mysteries remain unsolved, hidden in the dark. The ghostly architecture that underpins this entire cosmic web is made of dark matter. We cannot see it, we do not know what it is. Yet its gravitational influence is the primary force shaping the universe on the largest scales. It is the scaffold upon which the luminous galaxies are built. Mapping its precise distribution is one of the paramount goals of modern cosmology. Scientists are building new telescopes, designing new experiments, trying to catch a glimpse of this invisible substance. They are attempting to draw the full map of our universe, to chart the unseen continents and oceans of dark matter. And then there is the even greater enigma of dark energy, the mysterious force that is causing the expansion of the universe to accelerate. It is a phantom pressure embedded in the fabric of space-time itself, a cosmic headwind that is slowly, inexorably pushing the great superclusters away from each other. Over astronomical timescales, this force may eventually overwhelm the pull of gravity. It could isolate superclusters like Lania, turning them into lonely islands in an ever-expanding empty ocean. Our journey, our cosmic flow, may one day have no destination to reach. Understanding the nature of dark energy is perhaps the single greatest challenge in all of science. It will determine the ultimate fate of our universe, the final act in this cosmic play. So we stand here now at the end of our journey, looking out at the immeasurable heavens. We have traded a simple, comforting idea of a central anchor for a truth that is infinitely more sublime. The universe is a single, interconnected entity, a network of gravitational relationships, a silent symphony where the motion of one galaxy is tied to the existence of a billion others. We have learned that our powerful black hole Sagittarius A star does not orbit one thing. In a very real sense, it orbits everything. It moves in response to the grand collective will of the cosmos. And we, living on a small, fragile planet, circling a common star which in turn follows the arc of the galaxy, we too are part of this magnificent endless motion. Right now you are hurtling through space at over 2 million kilometers per hour. You are a passenger on spaceship Earth, which is a passenger on the Milky Way, a galaxy caught in a cosmic current flowing through the universe. We are all adrift on the same invisible river, part of the same grand procession. And for us, a species defined by our curiosity, there can be no more awe-inspiring realization. To know that we are not just observers of the universe, but participants in its deepest, most fundamental dance. A dance of gravity and light, of creation and expansion. a dance that has been ongoing for nearly 14 billion years and whose final movements are not yet written. The journey continues, the mystery beckons, and the dance goes on,